This is section 7.4, similar figures. Our objective today is to identify similar figures and use proportions to find missing measurements in similar figures. Let's begin by reviewing how to solve proportions. A quick reminder that to solve proportions, we do our cross products. 4 times x makes 4x, and 9 times 15 makes 135. We then divide both sides by 4, and x equals 33.75. In the other example, we do our cross products, 31 times x and 42 times 19, which is 798. Divide both sides by 31, and we get x equals 25.74. Our new vocabulary words. Similar figures are figures that have the same size and shape, or the same shape, but not necessarily the same size. In similar figures, the ratio of the lengths of corresponding sides are proportional. So that means if I were to take AC over XY, that ratio would be the same as 7.5 over 11.3. Similar polygons are polygons in which corresponding angles are congruent and the lengths of corresponding sides are in proportion. Remember that those cross products have to be equal. So the angles have to be the same and the sides have to be proportional. So we're going to decide if these two rectangles are similar, and why or why not. The first thing we have to note is whether or not the angles are congruent. Well, if you notice, they're all right angles, and therefore all the sets of angles must be congruent to each other. Now we set up a ratio of our sides. Let's take 4 over its corresponding side, which is 3. Is that equal to 10 over its corresponding side, which is 8? Now, if the other numbers were anything besides the same as the first two sets, we would have to test every set of numbers. So now let's check our cross products. 3 times 10 is 30. 4 times 8 is 32. Well, those are not equal, so this is not proportional. And the reason would be because the sides are not proportional. All right, rectangle EFGH has side lengths of 18 and 27. Rectangle LMNO has side lengths of 36 and 54. Try to tell me if the rectangles are similar or not. All right, to do this, we know that all the angles are congruent because they're both rectangles, so they have to have that in common. Now we check the ratios of the sides. 18 would go with 36, since they're both the shorter sides. And 27 would have to go with 54. Check our cross products. 36 times 27 is 972. And 18 times 54 is 972. These are equal, so they are similar because angles are the same and corresponding sides are proportional. Now we're going to apply this. You are going to design a poster, not in real life. A sketch for the letter H is shown. The letter will be 9 inches tall on the poster. If the two letters are similar, what will the width be on the poster? So basically what we're doing is we're taking our height, which we're given a height of 5, and we want to change that to 9. And since it needs to be similar, we have to have equal proportions. So this 4 in the original drawing will have to correspond to the thing we don't know. Now we do our cross products. 5 times x makes 5x. 9 times 4 makes 36. Divide by 5. And x would equal 7.2 inches. So that new letter H will be 7.2 inches wide. Try this one. The letter on the poster will have a height of 14 inches. What would the width be? All right, for this one, you can do it the same way as we did the last one. 5 over 14 equals 4 over x. Realize that you could have these fractions both flipped over as well. You could do 14 over 5 equals x over 4. Cross multiply, we get 5x equals 14 times 4, which is 56. Divide by 5, and we get x equals 11.2 inches. All right, now for the trickiest type of problem today. We have a triangle within a triangle. So I know that triangle ABC, this big outer one, is similar to triangle DEC. Now you can't do this on your paper, but you're basically just going to draw two similar triangles. We have ABC and we have DEC. Let's label everything we know. We know side AB is 18 feet. We know side BC is 8 and 16, which is 24 feet. That's all we know about that one. We know side DE is X, so it's probably what we're going to find. And we know side EC is 16. But since the problem stated that these triangles are similar, I can now set up a proportion. 18 over X has to equal 24 over 16. To solve, we do 24x equals 18 times 16, which is 288. Divide by 24, and x equals 12 feet. I very strongly recommend drawing both of these triangles as your very first step. It'll make it much, much easier. So these are the same two triangles, but this time I'm telling you that side DC, so right here, is 14 feet. What is the length of side AC? All right, well, just like in the last problem, we should draw our two triangles. ABC is the side of 18, and we decided this was 24, and we don't know side AC. And then we have DEC with the side of X and 16 and 14. We did figure out what X was in the last problem, but we don't actually need to use it. If you can at all avoid it, avoid using numbers that you have calculated, just in case you made a mistake. So now we still have this set of sides that goes together, 24 and 16. And we now have this x going with this 14. So x over 14. I guess I probably should have used a y there instead of having another x. All right, we cross multiply. 16x equals 24 times 14, which is 336. Divide by 16, and x equals 21 feet. Here's your assignment.